Thank you very much for this honorable invitation. And when I got invited to give this speech, I was thinking I will go directly into some direction of deep learning, transformers, and everything what we do, fancy things we do in the lab. But then more I was starting to talk and also teach the medical students and also students who are in engineering and are in the space of evaluating the behaviors, the health state, and the quality of life. And talking about digital biomarkers, I do understand that maybe it's time also for me and for the others to understand what we're talking about and set up some vocabulary and understand where we are in the space. And then also I will propose and suggest what's the state of the art in the space and what needs to be done without so much focusing on our own research, but still mentioning some aspects. So thank you very much. This work is representing all the different collaborators and my team work. But let's start with a specific case of a patient. This is our end user. It's an older person, 70 years old, female in her kitchen, type 2 diabetes, heart attack, hip fractures. You can see quite so many comorbidities. She does love cooking and too much carbs. And for those of you who know something about diabetes, know that it's not that correct. And her healthcare kit implies this specific self-monitoring, glucose level monitoring little device, which she pricks her finger maybe twice a day, and she counts and she claims she knows her body the best. So she in a case that she's self-managing. The same with medication. She has multiple medication for cardiovascular disease, for diabetes, and then she's just adjusting the medication as she goes. And that's her wonderful cooking. And this is an example of very stubborn and comorbid patients who may need some help from perspective of our technologies. And I know this patient because it's my mother. And I guess you have somebody like her in your surroundings. Maybe it's your mother, grandmother. We can reflect. She's unfortunately not the only one. Our behavior patterns make up to 40% of our future health state and quality of life. We know we sometimes blame it on genetics, but unfortunately, by their behaviors are accounting for 40, and sometimes we even see a number rising to 60% of our future health. And what behavior patterns we're talking about is tobacco and alcohol, but actually something which is touching all of us is the diet and physical inactivity, which are accounting for quite some health state in the future. And we do know how we do like to measure behaviors. Maybe I'm definitely not the only one pointing out that many of you are already doing this. And if you cannot measure it, we cannot improve it. So that's why we have this new domain, recent domain, which is propelled by this emergence of new technologies, where we talk about behavior markers, behaviome as opposite to genome, digital biomarker, digital endpoints, and so on. So how is this behavior, how is the health being measured nowadays? So here I'm presenting like a taxonomy of the data, which is being collected in case of clinical decision-making. Starting from left-hand side, the behavior specifically is in many cases evaluated by self-reporting. So the patient-reported outcomes, there will be questionnaires, instruments, so-called instruments, validated instruments, questionnaires, surveys, and then the patient will be able to, the individual being asked will be able to evaluate their own behavior. And some of them, they have a diagnostic scale. So based on the outcome, some decision could be made. And then I will switch to the right-hand side, where we have a clinician who can observe the patient, do some tests, maybe touch the patient and have some inputs into this decision-making. Then the second box is performance reported outcomes, when we have for example, tests, imagine you are on a treadmill and you have a performance test for your cardiac output, or memory test for cognitive impaired persons or persons who are at risk of cognitive impairment. And the last box is technology reported outcomes, in which the original paper mentions this hardcore outcomes like biopsy or X-ray or blood tests, or some specific like hardcore outcomes being collected by means of technologies from the patient, from the body. The wearables are not specifically mentioned in the original paper in 2017. By talking to the authors, Nancy Mayo specifically, she's a very well-known person in quality of life domain, she agreed that the wearables are belonging to this technology reported outcome. But I will also point out in this talk how difficult is that sometimes to understand what's really this technology report outcome and what are the others. And then at the end, I'll just quickly introduce the observer and proxy, and just to quickly point out, these are other persons around the patient. It could be caregivers, it could be family members, it could be trained nurses, it can be other stakeholders who are reporting on behalf of the patient with respect to what's the behaviors. And the typical example would be if you are a parent, you are a proxy for a child, reporting upon the child behaviors and maybe symptoms to the practitioner. So here we have a data model, and whenever right now I'm going to later refer to PROs, patient reported outcomes, I will mean anything which is self-reported, and either it's based on the survey validated scale, or it's more like a free text. Well, when I refer to TECRO, I will let you know when I refer to the TECROs, which are defined originally in the paper as this X-ray and blood tests and on the other outcomes, hard outcomes from the body, or the wearables. This is a typical example of a questionnaire which a person would fill up. It's a Pittsburgh Sleep Quality Index, which has 12 questions in total, where there are questions about usual bedtime and other aspects. And the recall period is a month. So one of the questions would be that in the past month, how many hours of actual sleep did you get at night? And I wonder how many of you on the call would be able to answer this question accurately without looking at your smartwatch or smartphone, or maybe using some app or having some data support. So as you can see, this questionnaire, it's really a reference measure in sleep. It has the diagnostic value. Based on the value could be provided some aspects of pre-diagnosis. And the questions are infrequent, they're contextless. They're very subjective, rater-based. They're based on beliefs as well. We do know that we may not sleep well last night, and then our question will be biased towards what we think, what we think happened last month. Memory bias, burned on some. Maybe there's some questions which we do not want to answer because of social acceptability, right? So could be something about smoking or alcohol, where we do not want to disclose what are really our behaviors, and quite qualitative at the end. So these are the patient-reported outcomes. And the big picture is that at the same time, we are surrounded by technologies which is almost embedded in our wrists. And already many years ago, when we've done research at Carnegie Mellon, we've been looking how far is the phone. And our phone already was 88% of the time next to us. And we believe right now it's even more, given all this variety of resources which are there. But it's not just the phone. We do know that there's a lot of emerging technologies, miniaturization, battery, communication capacity, which then drives this development and deployment and operational factors of wearables. Wearables which are on the body. Here is the figure presenting of 438 different wearables and their position on the body. So starting from the feet to the head, there could be some which are anywhere on the body, but Many of them, they have a specific location on the body. You could have 12 different devices on the feet. And as I was making a joke, you may not be able to walk, but the devices will be there. And that was already in 2018. That was something which, thanks for my lab, we have scrapped all the different databases and look into what are these different devices doing, what do they measure, and actually how accurate they are, and all this. And the annotated wearable data set is available, which relates to the paper being published almost at the same time. So with these devices, I hope we all agree that we would like to enrich this self-reported paradigm with technology-reported data sets, and make it much more frequent, continuous, non-judgmental, more objective, quantitative, longitudinal, and context-rich, and any other adjectives we can add here. As, however, I would say it doesn't come that easy. The first thing is digital biomarkers. We all talk about this, and we all think we are doing it, but are we really doing it? So starting from the definitions of a biomarker itself. The biomarker, by definition by FDA in the United States, looking at the characteristics as an indicator of normal biological processes, pathogenic processes, or responses to exposure or intervention, including therapeutic interventions. And then it's molecular, histologic, radiographic, physiologic. So it's really relating to these technologies which are measuring something, some hardcore outcomes, as I would say, endpoints in our body. So is the blood, is the screen, it's the picture, it's something which is then measured by technology. And specifically in this definition is remarked that the biomarker is not an assessment of how individual feels, functions, and survives. So inside the function, we see that there's behavior. So it's like, okay, so biomarker is not an indicator of behavior. So what's the digital biomarker? And also, yeah, I would like to point out that the biomarkers, for example, when you look at how genetics is using genetic biomarkers for risk, susceptibility, or diagnostic, monitoring, prognostic, predictive, or safety, and again, risk towards propagating the risk to the others, to the children. These are really nice categorization of these different biomarkers being used based on this hard endpoints collected by technologies from our bodies. Now, starting from biomarker, let's see how FDA recently published Nature paper in which they pointed out what's the digital biomarker. Actually, they just added a specific set of characteristics collected from digital health technologies. So they just edited the original definition of biomarkers and added the fact that these characteristics are collected from digital health technologies. The digital health technologies encounter everything technology. It doesn't need to be connected, doesn't need to be wearable. It's anything which has something to do with technology, information, communication, storage, processing capacities. And then there is no specific statement. Is that not related to an assessment of individual fields, how individual feels, functions, or survives, or is that related? So that has not been made clear. But in the same time, FDA been with the paper and all over the news that finally we are going to need to stop misusing the term of digital biomarker because it's simply wrong. So FDA left us there with their Nature paper. The colleagues made a lot of effort, and it's really great. And then there are others who to take over this particular journey of what exactly is digital biomarker and why we may get it wrong. So getting back to our picture of taxonomy of these data sets which are considered in clinical decision making, then I would just like to say that the biomarker is, as originally mentioned by Nancy Mayo, is the hard endpoints, hard outcomes, the blood, the X-rays, and anything related to how our body is from a physiological, chemical perspective. And then the digital biomarkers would be in sense, other aspects of this data sets. And I'll come back to this further. So who is helping next in us, the community, and different communities, because there are computer science communities, there's medicine communities, there's behavior sciences communities looking towards this digital biomarker field is, and how do we define it. The colleagues from Digital Medicine Society, which is a recently established partnership between industry researchers and specifically pharma-driven, pointing out that there needs to be a way of standardizing things, standardizing vocabulary, standardizing tools, methodologies, methods, techniques, wrote a paper in 2021 when they pointed out that the journey from when we get it from the left-hand side, the journey from what matters to patients, so that's where there's the patient engagement journey mapping. What are the symptoms? What matters to be measured before we even approach anything, and we call anything digital biomarker? How about if we just agree what matters to be measured? Then what's the sensor? What's the sensor which can measure this? And then the next thing is the digital measure box, which is then correlating the sensor data with something which is coming more from this clinical standpoint, right? So it's a label. In computer science world, we call it label. We're looking for labels. These labels can come from clinicians. They can come from other technology, right? So there can be other chakras. They can be the blood or the X-ray. They could be diagnostic codes. They could be performance-based measures, right? We ask somebody to walk or not, or do some tests, and then we have a clinical value. Or in our case, for quality of life or behavior, it will be the patient-reported outcome as a reference measure in specific condition. And I would like to say that we need to be all careful about using the gold standard as a keyword, because not everything is a gold standard in this different domains. And myself, I think, and my students, we sometimes use gold standard when you talk about patient-reported outcomes, but in a sense, it's a reference measure. It's a standard reference measure which is used there, and it's how things are being measured right now. So when you get into this figure here and the first part, development evaluation, we are looking into what are these different sensors and how do they relate to what is known to be mattered in this clinical decision making, which either comes from a patient-reported outcome or clinical outcome or performance outcome or another technology, another tech role, right? Much more hardcore. And only then it splits into so-called context of use. And this context of use, it depends if it's clinical practice, clinical trial. In many cases, before it can get in clinical practice, it's to pass by clinical trial and show its at least relatively equivalency to current gold standard or reference measures. And then at the end, it could be called as a clinical endpoint. Not to confuse anybody, because the whole story, I could spend the whole hour discussing this figure and what is the state of the research. I'll just focus on the first part because as I will show you, we are mostly in the first part. We are from a health informatics perspective and from many different perspectives and even clinical trials. I can see we have a lot of aspects of developing new sensors or bringing existing sensors like our existing even off-the-shelf devices, Fitbits and others, and many of you most likely have it, the Swift things and then Oura Ring and others, and we're testing everything in the lab and then understanding what's this value of this data coming from this sensor and how does it relate to what is already in this clinical decision-making for this particular patient. So most of the efforts come in this basic statistics, understanding how do we summarize these data sets and how do we manage, how to bulletproof it against for sensitivity and and additional performance measures. How do we do machine learning in order to represent these different data sources into this what matters, this PRO or other clinical data, this label? And then in our lab, we also do now looking at different data sources related to physical activity, sleep, heart rate, and other self-reported, like, for example, stress. And we're looking how do we represent it and leverage the deep learning and transformers. But that would be another talk. I will continue right now in telling you where are the efforts and what are the challenges in this first part of this picture, where we are not yet into having validated digital biomarkers, and then we are going the direction of this digital biomarkers. And as Digital Medicine Society points out, we may be working on digital measure. We're looking into these correlations. The next step, if we zoom in into this box, the next step actually, again, Digital Medicine Society is helping, is this validation path, where first of all, there is verification. Is the sensor generating the data it's supposed to generate? So there's a verification of this new sensor, for example. Either we have a new sensor or existing sensor, but how does it relate to the sensor which is already established in the field? And in many cases, it will be some kind of tech raw. It will be some, for example, for activity, Actigraph, expensive and very validated device, and then how our off-the-shelf device is collecting this data and how the quality of the data matches. The second step is analytical validation, where we're looking at what the sensor gives, and is that something which can measure, detect, or predict physiological behavior metrics? And the third step is putting in the context, is that even clinically meaningful, right? So as I would point out again in this journey and looking at the state of the art, we are putting a lot of efforts in the first two steps. And then there are some clinical validation efforts, as I will mention. But in many cases, from computer science perspective, there's a lot of happening, this verification, analytical validation. We write our papers on high correlations, and sometimes we are, unfortunately, sometimes we're too happy too early. A dream result, for example, would be if we have some, this was a Fitbit, an example. I'm a bit sarcastic here. I better contact the authors before it's too late. Using Fitbit and correlating with the clinical outcomes after the surgery, the authors point out for 73 patients, they point out a specific threshold of 4,274 point steps, which had significantly higher odds of severe complications. And I challenge this paper on different levels of analytics, but the first thing is that Fitbit is not that accurate in measuring steps. So what's exactly this 4,272 steps? And that is not specifically how do I say, bulletproof and validated way of approaching this development of this correlation, this digital measure. Another dream result I would like to show you as an example is where Verily has put a lot of effort in developing this, like a Parkinson case on their own smartwatch. So they have a full control on their device, and they ask the patients to have this different test at home. So it's a standardized test, which normally happens in the clinic, where the patients are seated and raising arms and up and go and up and go. So the device was helping to guide them through this standardized test. And then device itself is the tech raw, there was acceleration, there was analytics, algorithmic, and it showed very high, moderate to strong correlations with this consensus perf raw, right? I told you the perf raw was the second box on the right. So you may say, this is great, they correlated very highly, then they get these devices, they deploy it, and the Parkinson patients could be evaluated from perspective of the performance. And then what happens? The FDA rejects their they watch their device for this Parkinson assessment. What's the reason? Because there's not enough evidence that the criteria evaluated in assessments were meaningful to improve patients' life. Unfortunately, when you look at this abstract, they already say it's not really meaningful for the patient's daily life, but it's their first step in developing some evaluation of functioning for the Parkinson patient. So again, where did it go wrong, right? So we may ask yourself why FDA has done so and what else could be done instead, because the performance reported outcome, the specific test is like a reference measure for evaluation of functioning Parkinson patients. And then another type of journey I want to tell you, it's Actigraph, and it is one of the interesting ones because it has been deployed. Actigraph is a wearable, as many of you know, and it measures activity. And it has been deployed in a cardiopulmonary study where the intervention had nothing to do with Actigraph. It was nitric oxide versus placebo, and it was an inhaler given to the participants. And the first thing which the study investigators were looking for was one of the outcomes, 6 minutes walk test. So it's a performance-based assessment where the patient in clinic is asked to walk for 6 minutes, and then we evaluate how many meters. And that was like a reference measure, once again, understanding if the lungs capacity and the overall functioning status of the patient is increasing. So unfortunately, that was not statistically significant, but then fortunately, at the same time, the patients were wearing the Actigraph, and the Actigraph was then, the data has been leveraged to analyze their moderate to vigorous physical activity. How about that? And that was so-called exploratory endpoint. So no, that was not specific aim in the study, but still it was consented for, of course, and then monitored and analyzed. And only later on, it came that it was statistically significant, as opposite to what they were expecting, the 6 minutes walk test. So how fascinating. And here I'm talking about moderate to vigorous physical activity in daily life. So we're talking about daily life. We're talking about daily life behaviors of the patient, just wearing it at the same time going through this intervention. And that was a recent case where this FDA then endorsed the Actigraph as this endpoint, as even a primary endpoint in phase 3 following this particular medication. Evaluation of this medication. So how fascinating, right? But it's still ongoing study. So it was like a surprise, but maybe that's the journey towards the result. Not setting up specifically, collecting a lot of data, but that's also our challenge in computer science. And I see also for my students, we try to collect as much data as possible just in case. And then sometimes it's really maybe not ethical. So also we need to think about this. Well, the bigger picture, I don't want to only talk about the research in my lab. I would like to also link you to different resources. So Digital Medicine Society, again, very dynamic society, very useful, very really curated information. So they have, here we have a link, the library of digital endpoints. So you see also they use another keyword, digital endpoints. And they, you can find a database online. 366 clinical trials are evaluated, and it mostly musculoskeletal, mostly activity is evaluated. There's some glucose, there's some sleep. And you can see, as you remember the box when I was finding, like, where are we standing? We're standing in the first verification, technical validation steps, and many of these clinical trials are there. The second one is another database, which I will recommend for those who are interested what's happening in technology, is 438 clinical trials, and it's feasibility studies database. And again, if you look there, you also find this a lot of different clinical trials. Also, there was quite some glucose, I remember. And you'll see which also pharma and which condition and which endpoint, primary, secondary, tertiary, exploratory. Well, and getting back to what I can tell you about state of the art in the crazy part, like before even getting to clinical trials, together with my very good friend, who is a medical doctor at Stanford, I said, well, I will never learn what's in this quality of life, because I will just spend all my days reading the articles, and the quality of life is such a vast domain. I will never do that. I'll better give up right now. And she actually encouraged me. She says, okay, let's write a book. Let's write a book, and actually let's go into understanding how do we decompose quality of life. So I also should mention the quality of life. There's existing 172 different scales and questionnaires you can fill in order to evaluate your quality of life. And there are so many different questionnaires depending on the gender, age, race. There could be specific for condition, and it's really a huge effort. The committee, psychometricians and other colleagues are defining like what matters. So here we have, when we decided to write the book, I said, you know, in my lab, because I give up on understanding all the scales. There was a moment I studied all of them, but it's impossible. We focus on the World Health Organization one and definition, which is universal and also applies to healthy individuals. And it has physical health, psychological health, social relationships, environmental. And it has so-called facets, which you may think about as the variables. There are 24 of those. And I'm happy to say that as of today, 10 years, lab exists more than 10 years right now. And we are working and researching or doing some computational analytics of 14 out of 24. And one day I'm hoping to say, wow, 24 out of 24. And also there's a more like holistic model, because so far I have to be honest, we also in different projects take this domain like activities of daily life or mobility or sleep. We take as a separate domains and we evaluate them and develop this different computational models called digital biomarkers. And in many projects, as most likely as we are looking into how do we monitor something in order to facilitate the behavior change, and hopefully we bend the curve of quality of life and let us be happier and healthier for longer. So again, getting back to the book, 24 variables, 24 facets, and the idea was we are going to co-edit, actually not write, but co-edit the book, and we are going to have 24 chapter writers, so experts in these different domains, and they're going to tell us what are the sensors and what's the current state of the art of going direction of digital biomarkers. What are the technologies which help to quantify these different aspects. And as you can imagine, sleep already is, you may say, there are some devices which can monitor sleep quite accurately. I'm not talking about sleep quality, at least sleep duration, sleep placement, 24 hours. And then there are some domains, most likely psychological domain, when it's much more harder to have a device which is directly correlated and monitoring some psychological health outcome. So here I have a very short overview of everything which has been documented in the 600 pages book, where we annotated each chapter. We have invited all these experts, and then we annotated each chapter with respect to what aspects of physiology we see from being monitored and being mentioning in the chapter, functioning physical functioning. So how do you sleep? How do you walk? Where do you go? Do you even leave the house? And then aspects of psychological functioning, which is also related to interaction. Then there's social interaction, there's interaction with the environment, and then environment itself, so where you are and what's happening. So that's how we have quantified this different, from machine learning perspective, is this multimodal machine learning, which will be then used for quantifying this outcome, and that will be like a data stream which are coming as the inputs to our machine learning. So just overall view, when you think about us biasing the authors towards including everything on the body, so how everything on the body can monitor a specific variable, can we get the sensor? We're not interested in we have biased the authors. As I said, we invited authors who are experts in something on the body or on the body. As you can see, there was no cameras, there was no audio. Actually, audio also was excluded unless critical, like in emotion recognition, there was a part which is mentioned. And then no audio, no external devices, not smart home, smart things around us, but anything on us, around us, and maybe a laptop or a personal computing device, tablet, which is included as a sensor. So what do we have here? We have a cumulative view on what kind of channels has been discussed in each chapter. This is for the whole book. Huh? What has happened? What kind of data source would be having a strong signal for quality of life or specific sub variables or the facets? Temperature and heart rate has been mentioned the most, as the font size is the largest across all these different chapters. And this heart rate, respiration, a lot of heart rate. And then from functioning, we have accelerometer, as expected. Accelerometer as it recognizes where if we are functioning, we are walking or not, sleeping or not. And then it was interesting, screen on off as a sensor, which we also have this experience in the lab as an indicator of sleep, for example, has been mentioning also quite some chapters. The next one is interaction and social activity, social network activity, or social messaging activity. So, like most likely on the tablet or on a smartphone, what kind of applications are being used. And then in the context, as expected, would be location was mentioned as a source of information, then light, temperature, and others. Well, so that's the cumulative view. But I have another view on this, on the whole book. It's like when you look at all these inputs, right? And I told you from the left, physiology, function, interaction, context. First of all, we also ask, like in each chapter, we're very much biasing the authors to tell us what's the current state of the art, what's the current reference measure, what's this gold standard, which we don't want to call standard because in many cases it's not the gold standard, but what's the current reference measure, standard measure of monitoring this particular domain, like imagine self-esteem or a body image or positive, negative emotions, right? So we needed that the authors tell us this, and then they go into particular technology. And then here you have 24 chapters. So first of all, how many, in many cases, it's self-reporting, which is the standard measure of in specific domain, except from memory and thinking, which is in psychological health, where there's a lot of testing. And then also in positive and negative feelings, there was a lot of other inputs, which is like, as I said, visual, vocal, verbal, there's hormonal, cortisol, and others. And in some other, like energy fatigue, there was also some tests. But in many cases, we've been trying to bias the authors also to tell us what are all the possible self-reporting, which is possible in this particular domain. And then this is visualization. This is like a heat map, and tells you which is the data source from which particular signal we got the most of the signal in specific domain. As you can imagine, physical health, psychological health, physical health specifically, it was physiology and functioning, a bit of interaction, and then psychological health, there will be a lot on the body. And then when you get into environmental, there is much more context as a sensor, right? Context as a sensor. So here we go. This is the book. It took quite some time. So for any of you who want to write a book, I'll be very happy to mentor you. It will take a while before I can write a third one. The previous one was digital health. I think it was easier because we've been really learning, and now I was much more specific on my research questions and what I really would like to get from the book. And that was also like what is always speaking silently is the body, like biasing the data sources of being physiology, functioning, interaction, and just on the devices, on the body and the smartphone and to the tablet, but nothing else. It's really like how the body speaks by interacting. But I really would like to emphasize here that we need to really take care of the individual, and there's a lot of human factors which will then influence our development in this domain. So first of all, how do people even feel about all these different devices, including their smartphones? So here we have answers coded answers from 200 chronically individuals, which was my data collected at Stanford, I remember. And then there will be around 20% of the population which will always say no, and we have to respect it. And they will be like, no, because don't give it to me. I don't need it. I don't mix my phone with my health. I really do not approach me. And that must be what I always say to the students, just always respect. You are a designer and you really want well, but not everybody is really your user. It's not everybody is your user. So some of them are your users, I would, and then there is an aspect of education. There's privacy, complication, it's inaccurate, it's privacy, where is my data, sleeping at night, and all these different questions. But the most important, and I will not go due to short of time because I would love to have some discussion explaining, but it's a lot about cumulatively, you look at all this, I do, but, I do, and, I do use it, and I will use it, and you have something new for me, I can use it, but, and, how does it make me feel? How do I interact with it? Is the battery not too short? Is that not too difficult? Is that not leaking data to social network without my knowledge, right? So there's a lot of design implications from using all technologies. So when we get into all of this and the human factors, and then getting back to our point of developing our digital biomarkers, where the quality of the data of the sensor will then define the further pathway, right? And even, for example, the pathway of deciding if the particular medication works or not. There's a huge, not just that there's a huge effort right now in terms of statistics and sensor development, everything, but there's so much we still need to be doing from perspective of incorporating these human factors that I'm afraid, or no, I'm not afraid, but we're going to work on this for a while, and it will take some time before we develop this very robust endpoints, these digital measures and digital biomarkers. So we are busy, and we definitely need to work together with behavior scientists and listen much more to the users. If I have time, do I have another few minutes?
Yes, you do have time.
I will give you a sneak preview of our research on the specific variable, which is the sexual health. And what has happened is that because as a computer scientist, I realized I'm lacking some tools in medical space, and being curious as I am, I I went as a student for a 2-year program in clinical sexology, and that has been a work of myself, and I am already at the level of writing a thesis and finalizing. So I want to show you also further results which we got in this domain, and also point out that it's just fresh off the press, so any feedback is welcome. So sexual health, when you start defining sexual health, so states of physical, emotional, mental, and social well-being in relation to sexuality, not merely the absence of disease, dysfunctional infirmity. Well, not to criticize too much of the word harmonization, it's not really helping. This definition is very, this umbrella definition, and it's specifically actually, it's adapted from original 1946 definition of health, and it's not that even adapted. So then when you look at specifically of other aspects of sexual health, sexual function, so how the body reacts in different stages in sexual response cycle, most likely everybody heard here from Master and Johnson example of this particular theory. Sexual response, desire, excitement, orgasm, resolution, and then we have other. We do have other theories which came later, and the one which I have leveraged in my thesis was this circular model of Basson of female sexual response, and looking from perspective of where we start with the intimacy, the sexual stimuli, arousal, desire, and satisfaction. And later on, when you look at the literature, we realize how important is this decomposition of this elements and components, and how important also is, for example, desire, arousal, and satisfaction, how important is in defining sexual disorders. or really diagnostic purpose there. So, well, how do we measure it right now, right? So I had an excellent author, chapter number 16, right of the press, exactly what we needed. Well, 31 different instruments, different questionnaires, and as she pointed out very meticulously, it was systematic literature review. Some of them, they do not even have all these very important components, the desire, arousal, and then some of them they don't have. When they have arousal, they don't have desire, or the other way around, as you can see in the columns. And then also there is no really measure of satisfaction. It's just orgasm, like it may be not satisfactory. So it's very interesting. Also, I was like, wow, looking at all these questions, like how am I going to measure things? How am I going to measure it? So in order to start somewhere, start with human subject studies. I also will repeat the study at Stanford later this year. I just want to say it took 9 months, a really long time to get ethics approvals. If anybody wants to go through this, I will be very happy to mentor the person, because the ethics committee was not that happy to ask all these detailed, intimate questions. So we had asked the questions which are validated scales, not all 31. Then we had some open-ended interviews. I also added some wearable data just to see. There was a pilot study and wanted to see some preliminary data set. And then original idea was also capture the data from their smartphone, and additionally having their ecological momentum assessment about like desire, other components of their sexual functioning. But unfortunately, due to multiple reasons, was not possible. I was really happy just to keep talking to our individuals and also get their wearable data sets and do some specific analytics in our servers. And then the outcomes was, first of all, qualitative. I really did not find the proper paper or any specific state of the art of how even people use technology in sexual health, like very extensive and very qualitative. And specifically apps, I was looking for maybe people with some wearables and maybe some other devices, right? And then what are the implications for design of these technologies in order to already thinking ahead of time for digital biomarkers? What if I want to use some technologies, some sensors, some daily life technologies, as I said, for measuring some aspects of sexual health? How do I do that? Where do I start knowing what they do right now? What do individuals do? And then there was aspect of qualitative, and that's where I got into heart rate and glucose after orgasm. And I had some conditions. I had some awake and sleep conditions. Well, preliminary results, and really I'm just presenting you something from a helicopter view. Well, again, looking at the individuals, how do we measure desire, arousal, and satisfaction? And then when I get into this understanding how they use technologies, there was a lot of very interesting data coming out. The first thing is people use technologies depending how they feel and who they are, and that applies in general. Yes, we do have these different apps and wearables and things, but in context of sexual health, it has been even more emphasized and pronounced, like their sexual identity and who they are and how they use and what are their needs, right? Do they need to Google something quickly? Do they need to educate themselves? Do they need to meet somebody? Do they need to maintain their existing relationship? And also, how does it feel to use it? I'm talking about like apps, when they talk about using of the apps, and how they can leverage this interactive technologies for building intimacy. That's most likely, in most cases with existing partners. Then I would like to assure there will be much more quantitative input in my upcoming paper, and also there will be many quotes, and there will be some other aspects of understanding what really the individuals meant. The another thing is the futures, like the futures of the apps, the futures of the wearables. There was a lot about control. Do they feel in the control in this space, digital space, and what features support their needs, and how can they use it safely from perspective of safety, physical safety, but also from perspective of being safe in the digital space of exposing, for example, their different orientation and desires and needs. Then it's very much related to the data sharing. How do others perceive me? Do I belong here? Do they respect? Is that normal? Actually, using of some apps was just for getting context of what's normal, who is on the app and what they are doing and what's expected here. Then everything what has been used from perspective of mostly apps, we need to meet the needs of the individuals and understanding how do they save time, how they get satisfied, how they whenever there's a arousal, those also specifically for men, like how do I get satisfied quickly, right? So that was also one of the statements for the dating apps. And then also, attention, there is a different use of this different technologies depending on changing context. So much more emphasized than in use of regular apps, like unknown social context, unknown location, alcohol influences, stress may influence. And then a lot of stories about practicalities, which then hinder the way they sometimes propel, and sometimes make them use this technologies differently. So the interface design, specifically notification, specifically if they wanted to be informed about the partner being available or not being informed about partner being available in case they're cheating on the existing partner. So it was very interesting from like this social norms perspective as well, and aspects of interaction with others around. So the interaction notifications, application performance, if it's slow, that changes their opinion about me. So they are really much more aware than many years when we discuss with individuals, but use of 5G versus Wi-Fi versus no network or something. So it's not about the application interface, but it's more about if I don't answer, then what do they mean? So it's not really application performance related. Then accuracy, how far and why these algorithms are not working accurately if I want this, and then battery, do I need to charge right now, and then how much it costs. Actually, the cost was not an issue because most things are unfortunately for free, because then the data is being sold somewhere. So these are the human factors. I will be very happy to share with you the paper when it's out with all the quotes and additional information and psychological models supporting this. But as you can imagine, I came with the question, how do I measure desire, arousal, and satisfaction? Because it's important for diagnosing sexual health. And I'm in this, all of this, the only thing I can say that it's going to be hard to design some technology which is automatically, passively going to give consistent results for the individual. And then another little piece of results, I'll just tell you what happened when the question was also asked out of nowhere, like, do we have a lower nighttime heart rate after orgasm? And there's, these are more my 4 participants. I did not tell you also at the end, I only had 4 participants who finished the quantitative part with measuring with the different wearable data sets. So it's very preliminary, as you can see. And my hypothesis was like, when you sleep, so these are all the nights, they collected 4 to 6 weeks of data sets. All the nights, just draw all the heart rate, the mean nighttime heart rate, not resting, mean nighttime heart rate. So we know when they were all wearing the device, so we all knew when they are sleeping. And then here we have a condition was they needed to, it was observational study, but still they needed to report to me when they had an orgasm 3 hours before sleep at most. They were just giving me the dates, which are the days. So there was a little diary and how many of these events were there. And then my hypothesis was that the resting heart rate is lower after the orgasm comparing to the nights, which is not. And well, as you can see, there's actually the data is not conclusive. I did not put the statistics here. I think I missed it. Sorry, but yeah, basically there is no conclusion. There's some indication, for example, for participant number 1, we see no change. For participant number 2, we see change, but this is CPAP user. So it's uses machine which is regulating her physiology. So that may be not reliable. For participant number 3, it looks like a huge change, but we only have 9 data points. I think it was 9 data points for the second condition, and for participant number 4, it was also not statistically significant, even though it looks like, because there was not enough samples in the I think it was it was not enough samples in the condition 2, if I remember right. I may not be remembering right, but yeah, I will be very happy to share with you. There is the abstract is accepted at the conference right now, and the longer paper will come. And it's fascinating to see that technologies may not always be used for example, how do I derive satisfaction out of this, right? What has nighttime heart rate has to do with satisfaction, which I really would like to measure. So, well, back to square one. And I think many of us are there, and we're looking for collaborations. Thank you.
Katarzyna, this is wonderful. Thank you very much. Want to open it up to the audience if they have any questions. I have one, but if you have, raise your hand through Zoom. So let me ask it maybe, Kate, that the thing that intrigues me is these digital biomarkers are point measurements. From a clinical point of view, what is very exciting is their capacity to build in digital phenotypes, where you have both these digital as well as non-digital data streams coming together. Because what would be interesting for me, say, take the case of diabetes, we tend to see disease as a binary event like yes or no versus a gradient where people are on a spectrum of well-controlled to not controlled. So just curious, are you doing anything in terms of phenotyping and risk stratification?
That is correct. So looking for different groups. We're looking, for example, we had a study in which seniors in European projects have been collecting their physical activity and sleep data, so the Fitbit actually, for up to 3 years. And then every 6 months, we've been looking into more like a clinical input, right? So we've been looking, are they sick? We've been asking them to fill up a set of self-reports about depression, anxiety, overall health status, changing in eating habits or sleeping habits or something. So I do understand your need for much more nuances. So we've been looking into how do we classify the seniors from their perspective of daily life, and then we go even further, because then we classify them based on the season, because some seniors, it was in few European countries, and some seniors were living in the country where it's still warm in the summer, in the winter. It's not that cold, and then we had some seniors in the countries when there was really like snow, and it may have been dangerous to go outside. So this aspect of understanding, and then the challenge is that you don't have this very valid endpoints for prevention. Right now, we see some papers appearing about how many steps per day we need to take in order to manage our mortality differently in the long term. And then there's some endpoints, right, for what was that the other day? Something about like 7,000 steps per day. Maybe you heard about this. It's not, I mean, the 10,000 was like, something, and then now it's more like 7,000, 8,000 for older persons, and there's some already started to appear some evidence. And then like ideally it would be more like how far you are from the target, and also like what influence your activity anyway, and what kind of user, what kind of person you are. But it's not that we have a very specific endpoints against which we can label, like the labels, you know what I mean? We have a problem with the labels. Like if you tell me that I can do blood tests on person and then label something like my 1 day of my data of heart rate, you can label it somehow. I'm totally going to do that. But we have a problem with labels, and some of this self-reports, they have a 1 month recall period. This is like what I'm going to now summarize all my wearable data set in 1 month and just give you one number and see if it correlates. It's crazy. We're trying to understand how do we manage this very dense data sets versus the labels, which are not that accurate.
True.
Granular. Yeah.
Now we have Jonathan. Jonathan, you have a question? You want to unmute yourself and ask?
Yes. First, thanks a lot for this great webinar. I really enjoyed listening to your work, Katarzyna, and learning more about your book. So I have a question about generalizability. So basically, you said that you do a lot of effort to compare different type of measure, and I guess like having access to from data to different brands might have an impact. You mentioned that maybe when you measure your step with Fitbit, sometimes it's not that accurate. So I'm wondering, so how much can you generalize one specific biomarker over several different devices? And then how do you deal with the different proprietary software that maybe the device maker has, so which might be a problem for raw data access? So did you encounter that?
Absolutely, yes, absolutely. That's why when I was providing an example of Actigraph, they own the device and it's fixed and it's a pure accelerometer and the algorithm for analytics. But you say it's like they went through this pipeline, right, of getting through this, being this endpoint, because otherwise it's unfortunately it's a low generalizability. And what we do when I set up our seniors, for example, and wearing Fitbit, where they change the device, sometimes they broke it, so we give them a new one. And then, of course, the manufacturer also updates, right? We do not keep the same device for 2 years, the same software release. So we've been recalibrating our algorithms, but at the end, what we've been looking for is how do I say, grouping of people and what's their level of activity. So we almost did a qualitative analysis of their daily steps and sleep, and looking at the trends, at the high level trends, and not looking at the detailed step-by-step level, because that's impossible. Yeah, the generalizability. If you don't have if you don't own the device, and if you don't know what happened from perspective of how the data is collected and then analyzed and pre-processed and shared with you, then it's really impossible. Yes.
Well, Katarzyna, thank you so much for making the time. Be very unusual and very interesting work that you are doing. I hope you'll circle back and come back to you. I want to thank also the audience for joining us. This webinar is curated on mHealth Hub. And if your colleagues are interested, they can always access it asynchronously. So I thank you all for joining us, and we'll see you at the next webinar.